Okay guys, welcome to another video. Today we're gonna solve this integral right here by the method of integral by parts, but we're gonna make a little tricky method, which is the algebraic one using integration by parts. So first of all, we're gonna use this rule right here that you must completely memorize, which is u times b minus the integral of b du. So with this formula, it's the integration by parts. We're gonna start solving our integral right here. So before we begin, we have to take into account some hierarchy stuff for establishing our best or optimal candidate for you. So if you guys know, there's something called this rule, ladder, which is for inverse, logarithmic, algebraic, trigonometric, and exponential functions. Okay. So in this case, we just got that we have a trigonometric and an exponential one. So the one who is gonna be our u is the trigonometric one. So we're gonna establish u as cosine of 3x, and now we're gonna establish our dv. Sorry. dv equals the other function, which is e to the 2x. Then we have to determine the derivative of u, which is negative sine of 3x times 3. And then for this, we have to establish only b, okay? So for establishing b, we're gonna take the indefinite integral of e to the 2x. As we have another function within e, we're gonna solve this integral by u substitution, a simple and easy u substitution. Okay, so we're gonna determine u as 2x, and then we have the indefinite integral of e to the u. We're gonna differentiate u, which is 2 dx. We're gonna solve for dx, which is du over 2. So for this, we're gonna multiply what we have just got, and our final integral is 1/2 times the indefinite integral of e to the u du. And we just know that that derivative or integral of e to u is the same. It's e to the u. So we're gonna just substitute our real value of u, which is 2x, and this is our integral. So we just defined b, okay, as simple as it is. And we're gonna use this formula that I told you at the beginning, and we're gonna start solving. We're gonna use u, which is cosine of 3x, b, which is the one we just established. We're gonna put the 1/2 right at the beginning for simple terms, times e to the 2x, right? That's minus the indefinite integral of, again, b to the 2x du, and we're gonna use this term right here, which is negative sine of 3x times 3. Okay, so once we got this expression right here, we're gonna just make it simpler. And for this, this part is gonna stay the same, minus, okay, here we have two negative signs, so it's a positive one, indefinite well, before we're gonna move these independent terms outside the integral, so it is 3.5 indefinite times the indefinite integral of our two remaining functions. Okay, and for this we're gonna make we're gonna apply the same principle as the first one. That's why it's called integration by parts. Okay, then we're just gonna make a subdivision here. We're gonna use the same rule, ub minus indefinite integral of b du. Okay. Now we're gonna establish our candidate u, the same, the trigonometric function, which is sine of 3x. Then we just have to differentiate it, which is positive cosine of 3x times 3. And then we got our db, which is e to the 2x. And well, for saving time, this is the same integral as right here, so we're gonna just copy the result, which we know how we obtain it. And okay, okay, so we're gonna start solving for our terms. First we just have u, which is sine of 3x times b, we're gonna put 1/2 at the beginning, times e to the 2x minus indefinite integral of b, which is 1/2. Sorry, 1/2 times e to the x du. So we're gonna put our du right here. Also, cosine of 3x times 3. And as we just done it with this part over here, we're gonna just simplify our expression. This right here stays the same, and as we don't have any positive or negative signs, we just gotta leave this negative sign as it is. Then we're gonna move 1/2 times 3 equals 3.5 times indefinite integral of e to 2x times cosine of 3x. And guys, here's where we're gonna apply our tricky method. If we can see this part over here, this expression is the same as this one over here, which we have already solved. So if we just get back to the beginning of our exercise, we're just gonna name this expression, the first expression we've got, as a variable. Okay, in this time, I'm gonna name it as capital I. So once we got this established as this variable, we're gonna substitute this minus 3.5 I, which is, if you guys analyze it algebraically, you can see that it's exactly the same. So once we got this, we're just gonna input this one over here over this over here. Okay, so oh sorry, it's not over here, it's this one over here. Okay, so I'm gonna put this arrow over here so you guys get a better side of this. Oh sorry. And this 3/2 multiplies all the terms we have right here. Okay, we just gotta, oh, and let's not forget that this is the same as saying this. Okay, we just gotta make sure this capitalized right here, because we're gonna make only the algebra. And okay, I think we're gonna start solving this part over here. So I equals this first part stays the same, plus multiply these terms, and these ones right here, and we just got this expression right here. And for you guys to see it in a simpler way, we're just gonna separate our terms by operations hierarchy, and you can see that we can see this like more clearer. And if the objective here is we're gonna get the variables that have I onto the external point, so we can substitute for I. Okay, so this term right here is negative, so we're gonna just put the opposite sign of it, and basically the other stuff just stays the same, you know. Okay, so once we got here, we just gonna make here a quick fraction sum, which is 13/4I equals all of these. I'm just gonna copy it and paste it, and now we just gotta solve for I. Okay, so this 4, beginning with this 4 is dividing, so we pass it multiplying, and we're only left with 13I equals 4 times everything here, and we're just gonna make it this right easy, plus 12/4 sine of 3x times e to the 2x. Then okay, so this simplifies to 2 and this simplifies to 3, right? So it is 13I equals to 2 cosine of 3x times e to the 2x plus 3 sine of 3x times wait okay, e to the 2x. Okay, this is 13, this is 13, and our final result lies here, which is only 13 dividing all our expression. And okay, I don't know. Okay, so we just got a result, our final result, and that's all guys. Here's our result, here's our first our initial derivative. I hope guys you like this video, and like and subscribe. Thanks.